So hello everyone. I hope you're doing well. Last Monday we have seen three main things. So I've seen the basic model, how we can code it on GAMS, and what are the different steps of running the code on GAMS, starting from writing the equations, variables, parameters, then the initialization process, then the calibration process, the calibration process first, and then the initialization process. And the second thing that we have seen, how we can run a simulation when we, we can do this only for exogenous variables, as we have said, and that was the case for labor supply, capital supply, and prices. And then the third thing that we have seen was how to interpret the simulation from an economic perspective. And we have seen that it's important to start with just the headlines of the simulation and what is the expected effect of the scenario that we're running. And then we contrast what our expectations with the numbers that we get from GAMS. So that's mainly the what we have seen on Monday. At the end of the Monday session, I showed you a slightly more complicated model, which is the simple one. And in the simple one, we have seen that the main difference is the existence of two sectors, not just one sector. And we have seen that in this case, there are several implications associated to adding an extra sector. Mainly, we have more equations, we have more variables. This means that we have to have a different set of assumptions for our macroeconomic closure. That's the third point. The fourth point, we have seen that we need more data, and that's why, if you remember, I sent you in the chat box the data that we need from the social accounting matrix for labor and capital of the two sectors. And finally, we have seen in terms of the GAMS code, what are the main changes? And we have seen that the main changes are the fact that we introduce first the set part that includes agriculture and industry, and then that we have to modify some equations and some calibration, the parameters in the calibration phase. And finally, we said that you will continue the rest of the model on your own, and we'll correct this in today's session. Okay. So the plan for today, we will start with having some codes that have been written by yourselves, and we'll try to correct them if we still have some errors. Then we will run a simulation using the simple model, and then I will show you another version, the third model that we have, which is a model with a government and with the rest of the world. So we're going to introduce some government flows like taxes, like public spending, and flows with the rest of the world, which are exports and imports. And we'll see how we can code this. So hopefully we're going to do this in the second session after the break. And at the end of the session, after the break, I will show you an introduction to dynamic modeling, how we can have some dynamic equations, and then we will see the case of a real model for the Egyptian economy that I have done to model some trade simulations in the case of Egypt using real data. Okay. So before I start, any questions on what we have done and what we're planning to do today, given that it's the last session? Any questions? Okay, so I remind you that just with the main assumption that we had in the simple model, so it was a Cobb-Douglas production function, it's a closed economy without exports and imports. We have two factors of production, labor and capital. We have two goods, agriculture and industry. We have a perfect mobility between labor and capital. and given the fact that we have that we have perfect mobility between labor and capital, so this means that we have one rent and one wage, there is no savings. And if there is no savings, so this means that there is no investment. And finally, we have the same assumption of equilibrium on the labor, capital, and goods market. So last time we counted the number of equations, we counted the number of variables, and we said how we can choose variables that will be exogenous in our model. And we said that labor supply and capital supply will be exogenous. We will choose one of the prices to be the numeraire of the economy, and that was the price of agriculture. And finally, we said that we're going to code this on GUMS. So I will stop sharing my screen now, and we'll start looking at your codes. So who would like to share his or her code? Any volunteer?
I can share my code, Dr. Chahir.
Okay, go ahead, Nadine.
It's appearing now?
Yes.
Okay.
We will go slowly over the model. So a title, that's fine. Closed economy without government, 2 factors and 2 sectors, exactly. And then set I. What is missing after the set? What do you think?
Let's see if like this. No, I don't know.
We need a slash after industry.
We need slash under industry.
After
like this?
Yes.
Oh, okay. Yeah. Okay.
Now everything turned to be either blue or black. Before it was green, because everything was assumed, or I mean was taken into consideration by GUMS as elements of the set that we have.
Okay.
What else do we need after the set?
What else can we add after the set?
Yes.
So I guess we should like close the order or something. The command, I mean, with the semicolon. Yes. The
semicolon to tell GUMS that that's the end of the set. And as you have seen, now the word variables became blue. So we have the variables. That's fine. The parameters. The parameters, no need to declare them with different
and industry, we can just say
exactly. This will not for you, instead of writing several lines that perhaps can be associated to some errors. Okay. So those are the
Me, Hassan.
Yes.
I think she put the bracket with errors.
With which errors? No, I mean they are correctly inserted, but I think perhaps the difference is that let me just check something if that's the case or not. Nadine, are they 2 quotation marks or two quotation marks of 1 or a quotation mark of 2? In other words, is it like that or like that? Sorry, I send them to Namis. Just a second. So, can you see in the chat box? What you wrote, is it 2 simple quotation marks or 2 double quotation marks? And Nadine, do you hear me? Nadine, are you muted?
Okay, I'm sorry, I can hear you, Dr. Chahir. I'm sorry. It seems that I muted myself when one was talking.
Okay.
It's like as I wrote it to in the chat box. It's like 2.
Yes, it's the double one. Okay.
Yes.
So let's continue. No, the correct one is the double one, not the simple one. So like what Nadine has written. So let's continue. Wage, okay. Equations, demand, revenue, okay. After that, move, scroll down, please.
Yes.
WLI, 1 minus alpha I, PI, WI, revenue, it's fine. Beta, okay. I mean, for prices, no need to have the quotation marks. You can remove them because it will be indexed over I in the calibration part.
In the calibration,
I can delete the quotation marks with industry and replace it with I.
But then this would mean that both sectors are the numeraire or
no.
Just, okay, I got it. Okay.
Currently, that's just calibration.
Yes.
PO, POI,
yes.
PO not P0. Are these O's or zeros?
Zeros. No. So no, they are O's. The zero
Sure.
has it looks different. This is zero. They are O's.
W, okay, for labor and capital, that's fine. Then again, the same comment, we don't need for when we calculate the volumes, we don't need to calculate this for each and every sector, because when you will be working on a real matrix, you will have 16 sectors or 60 sectors or perhaps 120 sectors, and in this case, you will not write 120 equations. So that's why in this case, it's better to have everything indexed over I. I mean, you can correct this later by removing the quotation marks with agriculture and just adding the I for identical equations. But we can do this, for instance, in the case of assigning the values to the variables of the base year.
Yes, I thought when you assign the values and you just split the sectors, I thought it should be like that throughout the model. That's why I split all the equations. Okay, I got it.
Okay, and then so you will correct this later, because, for instance, as you can see in line 88. That, for instance, here you forgot the second quotation marks, and that's why the rest of the command is green.
Oh, okay.
So you have to add a second quotation mark after end. No, the first end. The first end.
The first. Yes. Okay.
Okay. And again, so I mean, when you'll correct this, you will see that you will remove several redundant equations that do not help you, or perhaps actually, as it was the case, they might be a source of new errors. So that's why it's better to reduce the number of what we write if this will not alter the code itself.
Okay.
Then moving to the initialization. Rev L, okay. So again, the same comment for consumption, Y, K, and L, and prices. They have to be just with an index I. No need to have the agra and ind. Okay.
I thought for the prices that there
Yes,
should
yes,
be
I will
one
not-
of them.
Just a second.
Okay.
Come to this in a few seconds. Just a second. Okay.
Mm.
So an important question here. So if we write P, Nadine, go to line 114, please.
140. Yes.
Yes.
This time.
Delete the quotation marks and industry.
Leave the quotation mark. You want me to remove the quotation? Delete them. Okay.
Yes. And write instead of industry and the quotation marks I.
Okay.
And then after the quotation mark, the same thing. So GUMS in this case will understand that GUMS will understand that, just understand that prices here are endogenous, okay? But no, just a second, don't erase anything.
No, I was just I did something wrong, so I was just writing it again. Nothing.
So now for GUMS, all prices are endogenous. But if we write in line 115 a new command telling GUMS that agriculture is fixed, then in this case GUMS will understand that while all prices are exogenous, while all prices are endogenous, only one price will be exogenous. So that's initialization part. There is an error because in general we put the bracket after the L, which means that it will be P. Go to line 114, please. Dot, delete the bracket and I. Delete them. So it will be P dot L and then bracket I. So we have the bracket of I after the L. Okay? And we have to do this for all the sectors and all the variables that are presented above. So in other words, we tell GUMS that it's fixed or it's endogenous, taking into consideration the sector dimension, which is I. That's why we put the sector dimension after I, not before I. Okay? And then the last part is correct. So Nadine, you will have first to remove redundant equations. That's one. Two, you will have to correct the initialization part. And three, you will have also to remove the 1.2 that we multiply by LSO, because currently we want to reproduce the model without a shock. Once it works, we will introduce the shock later. Okay? So please do these modifications. And stop sharing your screen. Thank you.
I wanted just to ask something. The beta in the model, I did it wrong, right or wrong? Because I wasn't sure if this is how we deal with the beta or not.
Share it again, please.
Generally, the beta in the parameters and everything, because in the simple model we didn't have beta. So I was wondering if I dealt with it in the right way or not.
But I mean, in the declaration, yes. But again, no need to declare for beta agriculture and beta industry. It will be beta. And then go to the calibration part. Beta, it's well, what please? The others will reply. In beta Z that is divided, that is equal to revenue divided by portion. So in this case, just a second, please. T'as terminé là? Ok. Je ne sais pas encore, mais en tout cas, je t'envoie par mail. Et pour qu'on essaye, on dîne ensemble. Ok. Comment? Ok. Donc, peut-être, pas de souci. OK, parfait. Merci, merci, Jérôme. Sorry. So, beta here is defined as revenue divided by POCO. What do you think? Is that correct or not correct? Abdullah, what do you think? Any ideas? Salah Eddin, any insights on beta 99, 94 and 95?
No, I'm here.
We cannot hear you.
Now?
Speak, please.
Now you can hear me?
Yes.
Oh, sorry. Because I'm sitting with Abdullah in the same room, so we have to deactivate the mic and switch devices at each time. So in line 94, right?
Yes,
I think
94 and 95.
I think that agriculture should be replaced by the index I.
That's one thing. But what is more important?
Revenue.
In general, what is the economic definition of beta? What does it represent?
It's the share that we dedicate for the consumption of the good I.
Exactly. So in this case, it's the share of a certain good in total revenue, right?
Yes. Yes.
The opposite. Over the revenue. So that's the first thing. The second thing, don't change it now, Nadine, because I want to highlight an important point. Here, what Nadine has written is beta equal revenue divided by P multiplied by C. The way GAMS will understand this, it will be beta that is equal to revenue divided by price, and we multiply all this by consumption. Why? Because the power of the division and the multiplication is the same. So this means that at the end of the day, what Nadine is doing in this equation 94 and 95 is that she's dividing the revenue by the price, but multiplying the revenue by consumption. So that's why, in order to make GAMS read the denominator as just one unit, we need a bracket before the price and a bracket after consumption. Otherwise, GAMS will not understand that we're combining, that we're multiplying prices with consumption. Is that clear? So Nadine, in this case, you will have to do two things. So you will have you have to add the bracket. And second, you will have to put the numerator instead of the denominator and the denominator instead of the numerator. And then replace the indices with I. So I will give you 15 minutes from now, okay, to do these changes in your code. And then I need to double check that everything is well taken into consideration in terms of the way we do the initialization, in terms of declaring the variables and the equations that have more than a dimension. And third, in terms of the calibration of the new parameter beta. And then we will run two models of your code. So now it's 4:29. Let's take 10 minutes and then we see whether you finished or not. So we will share some screens at 4:40. Okay?
Thank you, Doctor.
If you have any questions, please send me in the chat box. Are you done or you need some more time? More time or you're done? Have you finished the code or not yet? Okay, the others. So Rania is done. What about the others? Nadine is done. Who else? The others, do you need some more time or that's fine? So 3 replied. Okay. The others, after Abdullah and Salah ad-Din. Okay, so we still have some people who need some more time. So let's have 5 more minutes and we start at 4:45. Okay. The others, Nadine, Chebnem, and those who finished, try to run your model and see what you get. Because if you still have some syntax errors, you can correct them. And if not, we will see what are the remaining errors that you still have. So we'll start again at 4:45.
Okay, Dr. Shahid, that's just a question. So we have to remove the part that we have from the basic model that we put when we calibrate, when we create a file called results and everything.
Yes,
right?
I will send you this in the chat box. You will add before the part that you want to deactivate this command. Sorry, I sent it privately. So you will have to add before the text this command, and at the end of the table that you wrote, this command. So on text and off text tells GUMS that all this part is either the part that we don't want you to read. I mean, between on text and off text, it is the part that will not be read by GUMS. So you will have to put it. You will have to put it before the word parameters that we had after solve, okay? And we put off text after the end of the table, after this part where we had the colons, put, and so on. So that's the idea of on text and off text. Okay, let's start. So who would like to share his or her screen? Any volunteer? Rania, okay, please go ahead. Okay, so let's go through your file first. So the variables, okay, a very minor comment, but it will be important later. As I said, it's better to align all your labels and all your variables, because when you have a large file, this will be reader friendly, okay? It will be easier to read if everything is aligned. Parameters, scroll down. So as you can see here, beta is calibrated, is indexed over I. Then the equations, that's fine. Equations. Okay, and as you can see, we add the Leon variable to one of the equilibrium equations, exactly. Okay, and then the calibration, that's fine. For the data that we need, it's fine. Then we calculate the volumes, correct. Income, okay. Then beta, it's correct. Income, CL, YL. Okay, so here what Rania did is correct, but in general, so as you can see here in line, yes, this line, what is it, the number? Yes, so 105 and 106 probably, or 104 and 105. So what Rania did here is that she declared the price of industry as variable and the price of agriculture constant. In this model, it's correct. There is no problem. But why I said that it's better to not have that? Because if we have more than 2 sectors, this means that we will have to declare an equation for each sector. And this will be a very time-consuming process. So that's why it's better to have the general declaration for all sectors, and then to specify among those sectors which one are constant or which one are exogenous. Okay, run the model, please. Yes. So as you can see, we get an infeasibility of -16, which is fine, because this means that our infeasibility is 10 to the power -16. So we have 16 zeros and then 8, and that's perfect. And then when the model converges, we converge to 2.2 -16, which is still fine after 2 iterations. Then we have a feasible solution to a square system. Great. We move to the listing, exactly. But first, what we do, no, Rania, please go to Infez in the search box. In the search box, no, up there, in the, yes, exactly, in the search box. Click enter. So GAMS is telling us that no infeasibility is found, which is good, because this means that the model converges to a square system and that we don't have any infeasibility. And then at the end, as you can see, we have the model summary where we have the number of equations that is equal to the number of variables. Okay. Thank you, Rania. Please stop sharing your screen. Who has a model that does not work? No, Rania, please stop sharing your screen to let the others. Yes, thank you. Who would like to share the screen?
Dr. Shahir, I don't have a model that is not working, but the feasibility is not like what Rania showed us.
Okay, so
It has
please,
a bit higher value.
okay, show me the code, please.
Okay.
Okay, so here Nadine has no on text must be on text before the word parameter. That's the first thing. So click enter.
I saw
Yes,
that.
exactly. So now it's
Oh, that's what,
deactivated.
okay. I saw.
Okay, run again,
And
please.
listen to this. Okay.
So run it again. Okay, so as you can see here, the invisibility is 2.4, which means that we have the invisibility. But Nadine, did you run again? Because I can't see the listing. Where is the listing?
I don't know. In Gans Studio, the listing is not like in your version. It's appearing outside.
Okay, well, in this case, click on reading solution for model basic. No, but I think that's not the that's the solution of the old one. Close the process log.
Okay.
No, close the process log. No, not this one. Beside. Exactly, close this
yes,
one.
Okay.
Yes.
Okay.
Close the results Excel as well. We don't need it.
All the last
And
model.
basic, run now. No, it's still solving the basic model, not the. I think that's the problem that Chebnem had as well, because Chebnem was talking about a similar problem.
Maybe if I close the whole program and open it again, it goes out of his memory or something.
I mean, try to do so, but I think it's a bit weird because in general, at least I'm talking about GAMS ID because I use GAMS ID. Once we can work within the same project, even if we have two different GAMS codes. So Chebnem said she solved it, so you restarted, or what you did?
Actually, I opened under a new project because before I opened the GMS file under the basic project. So it was seeing the basic model first.
Yes.
But when I open a new folder, it's like a project, and then the problem solved.
Yes, but I mean, in theory, this must not be a problem, as I said, because within the same project, we can run several codes. So perhaps it's a new innovation in GAMS Studio that I'm not familiar with. But in any case, try to do this, Nadine, and let's see if it works or not. Share your screen again. Because, for instance, in my case, I'm running all the three models, basic, simple, and the open economy within the same project, which is, I mean, even in normal papers, I can run different simulations within the same project. So that's a new project or the same one? No, that's still the process log of basic, not simple.
I didn't create a new project from the first beginning because this version on Apple on Mac didn't show me any way to open a project. Maybe it's automatically opening a project. I don't know, but I didn't open a project from the first beginning. It was just a file. I don't know. Maybe if I copied all the code and paste it in new.
It changed nothing. So now it's not only Studio, so Studio and Apple. So two things I'm not familiar with. Click on the settings button.
The settings, yes. Dr. Chahir, you can see the window of the settings because
No.
the last time you, no, this is the problem.
It's the same thing. Okay, so when you click on, okay, so go out of the settings, click on the drop-down menu below the green arrow.
Green arrow in the settings.
No, not in the settings. I mean up there in the toolbar.
Oh,
yes?
this yes.
No, run and one GDX. That's another thing. Well, I mean, so perhaps until we check another code, we can, I mean, try to search how to open a new project in Apple, because I mean, personally, I don't know how to do it as I'm not an Apple user and I have to search for that. So you can search for it online until we check another model. Chebnem, perhaps you would like to share your model if you solved it.
Yes, but I have errors, unfortunately.
Yes, that's good. That's what I want to have.
Okay, I think.
Nadine, would you please stop sharing your screen? Okay, so now we have. So that's the code of Chebnem. Okay, as you can see on your right-hand side, we have some locations for some errors. So
Yes.
in general, we have to go sequentially. So please click on the first green line. Yes.
That's what. 86.
So here we have in line 86, the first error.
Yes, and I cannot find. Is it about bracelets?
What do you think? What is the error that we have here?
It's about brackets, maybe.
Exactly.
Yes. Is it too much?
So now we have a bracket for I, a bracket for alpha. No, we need a third bracket.
Yeah. Okay.
Exactly. So AI. So all of these letters are O, not zeros, right?
Yes. Oh.
Okay. So L alpha.
The
So-
semicolon before in alpha.
And the semicolon, yes, exactly. In line 84. In line 84, we need the semicolon.
Yeah, that's right.
And then after this, in line 90.
Yeah, this is about something about income, but I'm not sure. Maybe.
But have you declared it income or revenue? Income everywhere?
Income, yeah, income.
Okay, so go down, please.
I will try to write it again. Maybe I should, I don't know. One into break.
Sorry?
Maybe I should do like that. I don't know.
No need for these extra brackets. And even for the brackets before and after the price and consumption, we don't need them. So I mean,
I tried to find. I was trying to find the error. Actually, that's why I put these brackets there, but I couldn't be able to find what's wrong with this equation actually.
And do we have an equal sign between income and price?
Yes.
Okay, CO.
This is some kind of problem here, I think, about income, because this is the problem here also. Maybe GAMPs, I'm doing something.
Yes, because it must be ink, not ink O. It's
Like
ink. Exactly. And then, no, in the calibration, it was correct. It's ink O.
Really? So, sorry. So, why ink here then?
Because in the initialization, we tell GAMS that the income variable is an endogenous one, and it is based on inc O. So it's inc.l equal inc O.
Okay, okay, okay.
So add an O after inc.
Okay then. Mhm.
In the set, I mean in line 98, it must be inc dot L equal inc O.
Okay, I think I have to change here too as inc.
It must
Right.
be inc O in the parameters, yes. But then even in the initialization, you have to add the O as well. Do you see in line 98?
Yes.
Inc.L equal inc O. Exactly. And then P, we said that the bracket has to be after the operator. And so in line 107, delete the bracket with agriculture.
Yeah, yeah, I
And
remember.
add them after the fixed, exactly. So agr, exactly, close the bracket.
Yeah.
And then put on text before the word parameters. On text before parameters, exactly.
What should I put? Sorry.
Dollar on text. Dollar sign.
Sorry, I have to find the dollar sign. Just a minute. I don't know. I will change that.
I will send it in the chat box. You can copy it.
Yeah,
And
okay, because in my keyboard there's no.
so here you
Yes,
can you have to.
I can copy it from here.
So you have to add on text before parameters. Dollar on text before parameters.
Sorry. There's something wrong, I think. Sorry.
And
okay.
Dollar of text at the end, after the end of the code, at the end, at the very last end of the code. Exactly. Dollar of text now. Dollar of text. Exactly. Run the code.
Just a minute.
No need to select. You can run it automatically. So we still have some errors, but the number decreased.
Yes.
So the first error, error 36, as you can see, what we're being told is that we have a line.
I think just a minute. I have to. I think I need to.
To what?
I have to. I think I need to change this. This was inco, but I think it has to. It should be inc.
No, it has to be inc O.
It parameters.
That's the parameter. So this one is correct. Yes, I see what is the no go up. So here in the equation, in the equation block.
Here.
Where is the error? What do you think? What the other think? What do you think here? What is the error in the block, in the equations block?
It must be here. Is that one?
Exactly, because now the GUMS couldn't identify which one is the variable and which one is the parameter. So run again.
Oh, still. Okay.
Yes, there is an error here. No, go down. There is an error here. In line 90. Where is the error?
This should be inc.
No, it has to be inc O, because that's the calibration. What is the error in the calibration? What do you think? The others, what do you think? Where is the error? But please don't change the screen. Yes, Rania, go ahead, please. We cannot hear you, Rania.
Now?
No, we can't hear you. What is the error that we have here in the calibration?
Is it correct what I sent in the chat box?
It's correct, but that's not. I mean, what's missing? Because I mean, mathematically, it's the same.
Yeah, you are right, because I divided it then, the info.
Yes. So what is missing in the calibration?
It should
Sharafuddin,
be
what do you
beta
think?
O.
Rafa? Sorry?
For me, I thought it should be beta O.
No, it's beta, because beta is the same. It's a parameter, so we don't need to have.
I think
an
beta
O.
then equal.
We have already the equal. It doesn't change anything.
But we should divide inc.
Sorry?
We should divide inco 0.
No need, because
No, we should multiply.
We are multiplying the
Yes.
beta by income, so it's the same.
Yeah.
What is missing here in the calibration? What else?
Price of agriculture, maybe.
Sorry?
Do I have to write here something about price of the agriculture?
No,
I think
not.
she should put this PO multiplied by CO in the parentheses, right? It's like
No
one
need.
more parenthesis.
I-
Yes, good.
I've done that, but it doesn't change anything actually.
No need. It will change nothing.
It's about income.
I mean, we can put them between brackets and then divide by income, that just to make it better. But there is something missing here in the calibration. What is missing in the calibration?
Income need I.
Exactly. Income is the calibration of income is missing. So, and the calibration of income requires labor supply and capital supply. So that's why you have to copy and paste labor supply and capital supply, put them after the capital demand and labor demand. So cut and paste line 92 and 93.
92 and 9, yes.
Cut them, paste them after line 79.
Yeah.
Exactly. And then new line, and you have to calibrate income, because currently what you told Gums is to calibrate the parameter beta, without identifying the value of income. So
Yes.
new line, inc O.
Here is okay.
Yes, inc O equal LSO multiplied by WO plus KSO multiplied by RO. And as I said, the order is very important. That's why we have to put LSO and KSO after KO and LO to make the calibration of LSO and KLO volumes, not quantities. Okay?
Okay.
And that's why wherever we have inc O, Gums told us that there is an error because Gums couldn't find the value of inc O.
Okay.
So run again.
Still, I have something wrong with this.
So put a bracket before PO and after CO. Divide by inc O and delete inc O before the equality sign.
Okay.
And there is just a second, because we're still missing also. We need then error 499 unrecognizable items kept to find a new statement. So in line 105, what is missing? Exactly. Run again.
Okay.
So now what we have is a model that is working again. There is no invisibility because the invisibility is 8.8 multiplied by 10 to the power negative 16. And we have a feasible solution to a square system. Any questions on what we've done so far? Would you like to have another code? Abdullah, would you please share your code, or Rami, if it's working? If it's not working, I mean, if it's working, that's fine. So Rami, your model is working?
Could I stop sharing?
Yes, please, thank you.
Thank you.
Rami, my IT was still installing GAMS, okay.
Sorry, I have some problems with my GAMS and I couldn't run the code.
Okay, Abdullah, so it's working now, but trying to work on the code, okay.
Can I share because I have problems?
Okay, great. So please go ahead. So this will be the last code we'll work on, and then I will send you the correct code of the simple model on which we'll be building the new code of the open economy. So Oznur, yes, thank you. So what are the errors here? So in the initialization, let's go, okay, from the beginning. Go from the beginning, yes. Scroll up. Okay, down, please. Yes, go down, down. Okay, so here what supply, what is the problem here? What do you think? Between line 52 and line 59, what is the problem that we have?
I think there is space.
No, not a space, sorry. There is a more fundamental issue.
No, there is no space. I tried, but it didn't work.
It's not a space issue. What does make all the equations not working? What do you think? Hassan, Sharafuddin, Rania, Nadine, what do you think?
Where is it? I don't know where is it.
So Rania, as Rania said in the chat box, you forgot to assign or to add to the equations the index that we need, because we said that the supply equation, labor demand, capital demand, goods demand, and goods equilibrium have to be indexed over I. So that's why after the word supply exactly, we need bracket without a space. Exactly. The same thing for labor demand, the same thing for capital demand, the same thing for goods demand and goods equilibrium. Okay, just a second please. هو لو ولا مش مشترك؟ سأرتها لو غير مشترك. طب خلاص هبقى اشوف بقى. Okay, you have to replicate the same thing for the supply equation and labor demand. So add before the two dots the index I. Exactly here, yes. The same thing for labor demand, for capital demand. Exactly. For income, we don't need, and again, for income, there is a mistake because you added an index I for labor supply, capital supply, and income, while in reality they don't need. So you have to remove these indices exactly from the equation because they are not indexed over I. The same thing with income. Income is not indexed over I. Yes. Yes, exactly. What is missing in the capital equilibrium and labor equilibrium? What do you think? Is there anyone, but not Rania this time, because Rania is the only one who's participating. So what is missing in line 58 and 59? What do you think?
I think the sum.
Exactly, the sum. So after the equality sign, we have to add the operator sum. After the equality, yes, exactly, sum over I, sum bracket, over I, comma, No, you close the bracket after, exactly. No, I dot bracket, and then you close the bracket after the bracket of I, after KDI, I mean. No. Yes, you had to, yes, at the bracket here. You have to do the same thing with labor demand. So it will be sum over I of labor demand over I, yes, comma, labor demand, and you close the bracket. Leon is not indexed over I, and you have to add a second bracket, exactly. Okay, go down, please. For prices, that's fine. Here for the initialization, as we said, all the indices of I have to be added after the label, after the level suffix. So this means that the bracket I after Y, the bracket I after KD, all this has to be removed because we already added the bracket I after L. Yes. Exactly, you do the same for the others. No space after fx. No space, yes. And then the rest is fine. So run the code now. We still have some errors, yes, because here, do you see income is indexed over I while it's in line 57. Line 57, income is not indexed over I, so you have to remove the I. Exactly, and you have to multiply income by beta, beta I, in this equation. Yes, multiply by beta I. Beta I, okay. Down, please. Let's check if that's correct everywhere. So income, again, income is not indexed over I, so you have to remove it. Yes. And then what is missing in line 105? Exactly. Run now the code. So we're being told that there is an unknown identifier. Why? Because you have to put the agriculture between quotation marks. Yes. So all these errors are syntax errors. Run again. Now the model is working. Any questions on the way?
Thank you.
Any questions on the way we correct the errors of the GUMS code? Anything that's not clear of what we have done? Okay, so if we don't have more questions, now I will share my screen and show you the last part of the code that I will send you after the break. So as you can see here, now we have to create a different set of parameters with an index I for the variables that have an index I. So capital demand, labor demand, consumption, prices, and so on. We calculate the same variables that we need to calculate with the index I. And then we create also a new results file. And now we will introduce a new command in GUMS, which is the loop command. The loop command tells GUMS that you have to run a certain command over the sets that has been declared in the beginning. And the set that has been declared in the beginning is the set I of goods. So that's why for the variables that have an index I, in order to extract the results, we have to tell GUMS that this specific variable needs, has to be run over sectors I through the loop command. So that's why we add loop in the beginning. I will send you this, you will not write it just because we're running out of time. And then we tell GUMS to put again K, this didn't change. And then we add a new column that is called sector. And in this sector column, we put the index of interest, which is I, dot TL. And dot TL tells GUMS that the sector I will be replaced by the two sectors that have been declared in the initial set. Okay? Which means that for this loop command that I have here, we're going to have two lines in this table. A line for agriculture and a line for industry, right? And clearly for the variables that are not indexed over I, will not add an index I, so that's why it will be the same, and this column will be empty. Okay? So that's mainly the last part of the code. Now we will run the same simulation, but with an increase of 1.2 labor supply. And now the difference is that instead of reasoning in terms of one sector, we will reason in terms of two sectors. Before I show you the results, adding an additional sector to this model, conceptually speaking, how will it change the results? What do you think? Conceptually speaking, why the results will change if we introduce a second sector?
I think because of elasticity, because if we change something related to labor supply in one sector, it might pass it through to the other sector or vice versa.
Yes, but more specifically, what will make or how a sector will be more affected by labor supply than other sector? What is the main determinant in this case that makes one sector? So Salahuddin is saying because there is a mobility of factors across sectors. No, in theory, this perfect mobility will just lead to the equality of wages and rents. But what will make a sector benefit more from the increase in labor supply compared to another sector? What do you think?
In sector, labor intensive or capital intensive.
Exactly, it's the factor intensity. That will be the main thing. So that will be the only, the fundamental difference between this model and the other. And as you can see here, if we calculate the capital to labor ratio of the two sectors, so the capital to labor ratio of agriculture is a capital of agriculture over the labor of agriculture. So it will be 1/3, right? But the same ratio that's for agriculture. For industry, if I calculate the same ratio, the capital to labor ratio will be 3/3, which is equal to 1, correct? So this means that the capital labor ratio of industry is greater than the capital labor ratio of agriculture. And this will be the main driver of my results. Is that clear? That's why before running the simulation, we have to make sure that we understand the characteristics of the economy through the social accounting matrix. Why through the social accounting matrix? Because from the social accounting matrix, we can really determine whether a sector is more capital intensive or more labor intensive. So if we run the simulation, according to which we increase labor supply by 1.2, so the preliminary thing that we would expect is that the agriculture sector might benefit more from the increase in labor supply than the in industrial sector. Why? Because it is more labor intensive than the capital sector. Sorry, than the industrial sector. So I will run the simulation, and as you can see, now I have an invisibility. You can see the box that is generated or not. Can you see this dialog box?
Yes.
Okay.
Yes.
So it's 2.4 because initially we have an invisibility because there is a shock. But then GAMS runs several iterations until it reaches an equilibrium of 5.5 multiplied by 10 to the power negative 10, which means that we have a very low invisibility. So the model is correct. We have a feasible solution to a square system. Now we want to see the results of that have been generated by the code. Okay. So now let's see the file. I will open it. So now we will do the interpretation, we'll break, and then we start with the new model. So as you can see here, we have our initial shock where we have an increase in labor supply by 20%. Okay, so that's the initial shock. If labor supply increases by 20%, this means that labor demand will have to increase by 20% everywhere, and that's why labor demand will have to increase also by 20% everywhere. At the same time, capital supply didn't increase by assumption, and price of agriculture didn't increase by assumption because that was my macroeconomic closure. So that's why capital demand cannot increase given the fact that by assumption capital didn't increase. But if capital didn't increase, this and in theory we're demanding more capital because we want to produce more. So that's why the capital rent will increase by 14%. With the increase in labor supply, wages will decrease by 4%. So combining both of them, the rent effect with the wage effect, we get an increase in income by 14.6%. Bearing in mind that prices of agriculture are constant, but the prices of industry will increase. So now the most interesting part is this one. Why do we expect an increase in the price of industry? What do you think? Why do we expect an increase in the price of industry? What we have here.
I think because agriculture is more intensified in labor.
Yes.
So the most increase in labor moved to agriculture. So this makes output and production in agriculture more increase more than industry.
Yes. Exactly. You're on the right track. Go on.
Yes. In this case, the prices of industry goods should goes up to make to achieve the market good equilibrium.
Okay. So if we move to this, as Sharafuddin said, we move to the production side. We can see that production of agriculture increased more than the production of industry. And clearly this is due to the fact that agriculture is more labor intensive, and if it's more labor intensive, then it will be able to produce more than the increase in the production of industry. So that's why when agriculture increases more than industry, and bearing in mind that income increases in general, So consumers will buy more of the two goods. If they will buy more of the two goods, bearing in mind that the relative supply of one of the two goods has increased more than the other, so in this case, the price of, relatively speaking, the price of agriculture will have to increase. And if the price of the price of industry will have to increase. So the increase in the production of agriculture is greater than the increase in the production of industry, and proportionally, the increase in the demand for agriculture will be higher than the increase in the demand for industry. And this is due to two things. First, because the supply of industry is lower, and second, because the price of industrial goods has increased. So that's why the demand increases, but lower than the increase in agricultural goods. And clearly, from an economic perspective, and we conclude with that, the consumption of industry increases despite the increase in price, because we have two different effects. We have the price effect and the income effect. The income effect should have led to an increase of consumption by 14.6%. But at the same time, the price effect should have led to the decrease of consumption by negative 4.6%. So that's why at the end of the day, the increase in the consumption of industrial goods is just by 9.5%, which is more or less the difference between the two effects. So with that, we conclude the interpretation of the simple model and its simulation. We can clearly combine different simulations with labor supply, capital supply, with an increase in the price of agricultural goods. Any exogenous variable, as we have said, can be also subject to an exogenous shock. Any question on the first part? Okay, if we don't have questions, then we will now have our break. So we'll break for 15 minutes, and then we start with the last model that we'll see today, which is the open model with the government. And then I will present an introduction to dynamic models. So we'll stop now, and we'll see you in exactly 15 minutes. Have a nice coffee break. Of the government and the government and the rest of the world. Okay, so now we're going to change the model a bit. We still have a Cobb-Douglas production function, but now it's an open economy with government, and that's the fundamental change with respect to the simple model. We have two factors of production. We have two goods, perfect mobility of labor and capital between sectors. We have one rent and one wage. Again, there are no savings, but we still have, no savings and consequently no investment. But this means now that our GDP can be calculated as C plus G plus X minus M, because we don't have an I, there is no investment, and there are no savings. We still have an equilibrium in labor, capital, and goods market. We have a government, and we have a trade balance, okay? So that's the structure of the model. Now we have the production function, nothing has changed. We have the labor demand and capital demand, it's exactly the same. But now I just know, instead of having wage and rent, I'm writing them WL and WK, but it's exactly the same thing. Nothing is different. Compared to the initial model that we had. Then we have now, if you remember, the revenue of the economy before was just including revenue of labor and revenue of capital. But now we assume that we have a representative agent. So we have a representative agent who that includes both the government and households. That's why customs and taxes that represent the government revenues will be included in the revenue of this representative agent. I can just out of simplicity, I'm doing that, but at the same time, I can have an agent, a private agent that includes households, and a public agent that includes the government. Okay, and then this equation is identical to the last one that we had, where demand. I mean, here we have the demand function, where beta I represents the share of consumption of each good in total revenue. That's total revenue. And here we have the price of good multiplied by the consumption, right? And then this equation is a new one. I'll come back to this later. Those two equations are the same, labor supply and capital supply, okay? Initially, if you remember, we said that Y is equal to C, right? Because we just had some domestic consumption. Now we will have a different relationship because Y is equal to what is consumed domestically plus what is being exported. In other words, my total production will either be consumed domestically with this D or exported to the rest of the world with the X. So that's the first difference compared to the previous model, right? Then we introduce a new set of equations, but I will come back to these two later. I'll talk about these equations first. So here we have domestic price, the domestic price that is equal to the producer price to which we add the tax. Why? Because we know that if we have a government that collects some taxes, then in this case, a consumer will have to pay the final price that includes the taxes. So that's why in this case, we're going to distinguish between the domestic price and the producer price. What is the difference between both? It's attributed to taxes, okay? So that's the price that we call PD. We have a second price, PM, and this price PM is the price of inputs. We know that if we import a good from the rest of the world, the government might impose a duty on this imported product, which means that the world price will be subject to a tariff. And that's why we have here the world price of imports, right? To which we add 1 plus the customs duties that we call it DD. So this means that at the end of the day, we have two different prices. We have the domestic price that include taxes, and we have the price of imports that includes tariffs. As a consumer, my basket of goods includes two sets of goods, either imported goods or domestic goods. So that's why my basket of consumption that I will call C will have a price that I will call PC, okay? And this value is equal to the price of my domestic goods plus imports multiplied by the price of imports, okay? What does this conceptually mean? It means that at the end of the day, or I can write it this way just to show you what I mean. So here we have what I did. I divided the two sides C. So if C represents my total consumption, C represents my total consumption. D represents the share of my domestic goods in total consumption, and M, the share of imported goods in my total consumption. So this means that at the end of the day, the price of consumption will be a weighted average of the two prices, of the domestic prices and import prices. And what are the weights? The weights here are the share of goods in my total consumption basket. So the share of imports multiplied by the price of imports and the share of domestic goods multiplied by the price of domestic goods. And that's here what we have in this equation. So we explained this one, this one, this one as well. And this one is very simple because it shows our trade balance, which means that we assume that by definition, given the fact that we just have one country and one rest of the world, my exports have to be equal to the imports of the rest of the world. So that's why the value of exports is equal to the value of imports. Okay. The last three equations that we have to explain are this one, and this one. So dn and x. What, conceptually speaking, what do these equations represent? So in general, I mean, if we had time, I wanted to do the derivation mathematically, but unfortunately we don't have time because we still have a lot to see. I mean, in terms of the simulation, the code itself, and the interpretation of the results. But in general, to start with, if you remember when I was presenting the general idea of CGE models, we said that exported goods and domestic goods are not perfect substitutes. Why they are not perfect substitutes? Because in order to export my goods, I have to add some characteristics to these products. This means that, as I said, for instance, I will have to change the label of some products, for instance. This means that in order to make a product exportable, in order to make a product exportable, we have to have some additional characteristics that are added to the product. That's why there is an imperfect substitution between domestic goods and exported goods. We call this relationship constant elasticity of, it's a constant elasticity of transformation. What does this mean? It means that we have to transform domestic products in order to make them exportables. So the relationship between domestic goods and exported goods is what we call the constant elasticity of transformation. So that's the first point. The second point that we have on the relationship between imports and domestic goods, we have also a constant elasticity of substitution. And in this case, we assume that imports and domestic goods are imperfect substitutes because as a consumer, I do have a preference perhaps for both, because these goods, they are different varieties, different qualities, they come from different countries. For instance, I can consume a jeans that comes from Spain, Zara, for instance, and another jeans that comes from the United States, Gap. Both of the two jeans, they are of the same quality, but perhaps different varieties, different cuts, different colors. And I might want to consume also a jeans perhaps that comes from Italy, Armani, and that might be of a higher quality compared to the Zara jeans, for instance. So in order to model the substitution between goods of different varieties and different qualities, we have to do this through the constant elasticity of the constant elasticity of substitution relationship. And that's what we have here in the D and the M equations as well as the X. So here we have in the D equation that shows the demand addressed to domestic goods. Here in the imports function, we have the demand addressed to imports, and I will explain each one of them. And we have here the demand for exports. So what do these equations represent? The first equation shows that, if you remember, we said that my overall price of consumer is PC. And my overall basket of consumption is C. And that's why my overall price and my overall consumption, they appear in the two equations, because this represents my total demand. So the higher the price, the higher the consumption, the higher the demand, the higher the demand for domestic goods, and the higher the total demand, the higher the demand for imports as well. So that's on the presence of C here. At the same time, we have the price of domestic goods and the price of imports. And clearly, if the price of imports increases, the demand for imports decreases. And if the price for domestic goods increases, the demand for domestic goods decreases. So this captures the price effect. The last two sets of terms that we have are the sigma and the A. What does the sigma and the A represent? The A is simply a scale parameter. And the scale parameter shows here that we have like the A that we have, the initial A that we have in the Cobb-Douglas production function. It's just like an intercept or a parameter that shows the scale of demand itself. And clearly, if we want to calibrate this term, we will simply write AD that is equal to D over everything that we have on the other side, which is C multiplied by PC over PD to the power sigma, right? So those are the scale parameters that we have here. The last and most important term is the elasticity that we have here, sigma. Sigma here represents the elasticity of substitution. Economically speaking, what does the elasticity of substitution mean? It means the rate of change of the demand for imports with respect to demand for domestic goods when their respective prices change. In other words, the elasticity of substitution, it shows how the demand for domestic goods will change with respect to demand of imports when their respective price will change. Okay, that's more or less the idea of, I mean, the mathematical derivation is much more detailed and we don't have time to do that. But I will, that's very briefly and very roughly the idea behind. The mathematical statement is much more detailed. If you're interested, I can send you the derivation of that, but we don't have time to do the derivation manually now. So the idea of the elasticity of substitution, as I said, it shows how the rate of change of demand will change with respect to the rate of change of prices. And here I'm talking the relative demand of domestic goods versus imports, and for the prices, the relative price of the domestic goods versus. Okay, so that's the elasticity of substitution. We have a problem here. I said if we want to calibrate the AD or AM, I will simply divide all this term by D and I will divide all this term by M. And I know that I can normalize prices to 1 or calculate them from the formulas that I have here, so that's not a problem. The M and D, they come from the matrix. The problem here is sigma. How can we calibrate the sigma? What do you think? How can we calibrate the sigma?
I think from previous study.
Exactly, from previous study. And what do you mean by previous study? So exactly, like Abdullah said, it's exogenous. So which means that we will impose the value of sigma. For instance, we'll assume that it's equal to 2. which means that the elasticity of substitution is equal to 2. Okay, so the value of this parameter will be imposed. So that's for the demand for domestic goods and the demand for imports. The other thing is the demand for exports. The demand for exports, again, we have here an elasticity of substitution for exports, or an elasticity of transformation. We have a scale parameter that we have here, and then we have if we impose any kind of export taxes or export subsidies, it depends, because subsidies are negative taxes, so we add them also to this export demand function. Why? Because they will represent any kind of cost that is added to exports. So the higher this cost, the lower the demand for exports. One final thing, this ratio that we have here, which is PMW word over PI. If you remember, I mean, from the basics of international economics, one of the things that affect exports is the ratio of the price of exports with respect to the price of imports. And here, our exports are exported at a price PI, because that's the producer price, right? So the higher the producer price, the lower the exports. Why is that the case? Because this means that our exports will be more expensive, and this will lead to a lower demand. And at the same time, if our exports become less expensive compared to our imports, so in this case, this means that they will become more competitive, and consequently, if this decreases, so X will increase. So that's the structure of the demand for exports. That's economically the structure of the model. So we have seen here, before I present the code, several new concepts. The first new concept is the introduction of the elasticity of substitution and the elasticity of transformation. That's one. Two, that some parameters are calibrated, like what we have seen for the A and the alpha in the previous model. And here we have some parameters that will be imposed on the model, like the sigma. Third, when we introduce the rest of the world as well as the government, this means that we introduce new flows associated to exports and imports and some government flows. Finally, we see that the equilibrium now takes into consideration the fact that we are exporting. That's why my y is not equal simply to c, but it equals also to d plus, I mean, now it's equal to d plus x instead of y that is equal to c. Why? Because now my output is either consumed domestically or sold internationally. Okay? Any questions on the structure of the model from an economic or from a conceptual perspective? Any questions? Anything that's not clear?
The only thing, doctor, in the equation of the substitution between the exports and imports, I didn't get what is the small x beside the sigma in.
It's again, you mean the small x beside the.
The elasticity. This.
Just a second, I will open it again. So you mean this one?
It was in the power.
So you mean the, just a second, I'm opening it. So you mean this one, right?
Yes.
No, it's the same here, but we have a different parameter for export. So to distinguish between the one of imports and domestic goods, we have here a 1 for exports, but it's not a second term. It's just like a subscript for the parameter sigma.
Okay, that makes sense. Thank you, Doctor.
Other questions on the model itself?
Can you explain more about elasticity? It's elasticity for what?
So that's that this term is an elasticity of substitution. The general concept of the elasticity of substitution, it shows how the relative demand of a certain good changes when its relative price changes. What does this mean? So if I have the elasticity of substitution like that, so we have the elasticity of substitution. It shows how the relative demand for, let's say, imports with respect to imports, okay, changes with respect to the relative demand of domestic goods. That's the numerator. When the price of imports change with respect to the price of domestic goods. So that's more or less the idea. I'm comparing the relative demand for imports with respect to demand compared to the relative demand, compared to the relative change in the prices of imports and domestic goods. Is that clear?
Yes. So it's a price and quantity elasticity.
It's exactly, it's a concept of elasticity, but what we're interested in, it shows the relative change between two things. So it's the relative change of imports versus domestic goods, yes, compared to the relative price, or exports and domestic goods compared to the relative price. And I can do exactly the same thing for labor and capital, because I can have an elasticity of substitution between labor and capital, and so on.
Clear.
Other questions on the rationale of the model? Okay, if you don't have more questions, we can move to the code. So I will explain the rationale again, because unfortunately you'll not have time to do the code yourself. So now we build on the same model, which means that we will save as the simple model and add our new variables of interest. So we have again the same set. This hasn't changed. We have the Léon and all the variables, but now we will add a set of new variables, which is D, the local demand for domestic products, imports, exports, import prices, world prices. The variable PC, if you remember, we said that we have a price for the whole consumption basket, and we call it composite prices. Then we have the domestic prices. We take all these variables, copy and paste, that represent the parameters, but now we have also a new set of parameters after the A, alpha, and beta that are the old parameters. So we have the Armington coefficient for imports, and that's the scale parameter I was talking about, the A parameter, and the scale parameter for domestic goods. Tariffs, we have the elasticity of substitution. We have the elasticity of exports demand, sigma X, that we were just talking about. We have the scale parameter of exports demand, that was the gamma in my exports demand function. We have the foreign tariffs or any additional cost that we have. Customs duties, which is the value of tariffs multiplied by imports, and the tax rate that is imposed by the government. So here, those are the new parameters that we have in the model. Okay. Any questions on this part? We move to the equations. It's the same rationale. where we have the equations with their indices, but we have to add all the new equations that we had in the model for prices, for demands, for the equilibrium, for the trade balance, and so on. So everything here has been added to the equations. And then we start with the mathematical statement of the model. So the supply is identical, nothing has changed. Labor demand and capital demand are identical again, with the only difference is that I replaced the R with WK, but other than this, it's the same. Now my income, if you remember, we said that we have a representative agent whose income will include all the sources of income.
Taxes.
That are, just a second, that are income that comes from wages, that comes from capital remuneration, that comes from import duties, and that comes from taxes. And all this represents the income of our representative agent that will be later allocated to the consumption of different goods. And that's why here we have income. So WL multiplied by LS, WK multiplied by KS, plus the sum of the customs duties that we get from the value of imports, plus the value of taxes that comes from domestic goods. And all this is equal to income. Okay? Then we have the demand for domestic goods. And I remind you that here we use the price of consumption, that is the composite price. And the composite price is the weighted average of domestic prices with and import prices. Okay? Why? Because this consumption basket includes both imported goods and domestic goods. Is this clear? Any questions on this part? Okay. Then we have the two equations, sorry, that represent the demand for domestic goods and the demand for imports. So we have the scale parameter, as I said, and then the total demand, and then the relative price of domestic goods relative to consumption goods. And again, here, the relative price of imports goods relative to my overall prices. Then I have my total value of consumption, so PC multiplied by C, that is equal to what I consumed from the domestic market and what I consume from the imports market. The price of imports is equal to the world prices to which I add domestic tariffs, DD, that's the tariff rate. Then here we have the demand for exports that are equal to the scale parameter, gamma I, multiplied by the relative price of goods with respect to, of domestic goods relative to world prices. And here we have the elasticity of substitution of exports. Then we have the equilibrium equations that are very simple. So the equilibrium of goods is equal to what we consume domestically. I mean, what we produce is equal to what we consume domestically and what we export. Because if you remember, we said that domestic producers will either sell their products domestically or they will sell their products abroad. And then we have the capital supply here, the labor supply, nothing new. And we have the trade balance, meaning that our total exports must be equal to our total imports. And finally, we have here the price of domestic goods, because in general, if we have a government, the government will impose a tax on the producer prices. Because I mean, you as a consumer, if you buy a good, you will have to pay for instance, the VAT, the value added tax. So this is more or less the value added tax. So that's the mathematical statement of the model. Anything that's not clear in the mathematical statement of the model before we move to the next part of the calibration and the initialization? Any questions on this part? Anything that's not clear? No questions? Okay. So now we move to the calibration. And for the calibration, the process will be different. Why? For at least 3 reasons. First, because we need new data on exports, imports, domestic demand, labor, capital, all that. That's one. 2, not all prices will be normalized to 1 because some prices include taxes. 3, some parameters, as we said, will be calibrated from the literature, such as the elasticity of substitution. So this means that we need all these data from the social accounting matrix on labor, capital, exports, imports, and all that. But we'll have also to add data from the literature on the elasticity of substitution. So for the calibration, we'll assume that some prices are normalized to 1. These data, they come from the social accounting matrix. They are again fictitious data, okay? Then we have the 2 elasticity of substitutions that are taken from the literature. Those are the tariffs, right? 0.2, so tariffs are of 20%. And then we normalize the prices of factors of production to 1 because this will not alter the model. And then starting this part, we start converting values into quantities. So in order to calculate the quantity of imports, we have to divide the value of imports that we get from the SAM by its price. We do this the same for capital, for labor. Here we're converting everything from values to quantities. Then we calculate the value, the tariff rate itself, which is basically the share the share of customs duties in the value of total imports. Then here we have the labor supply and capital supply in terms of quantities. We assume that taxes are equal to 40%, 0.4. Then we calculate the price of imports with the same function that we had above, but based on the data of the base year. And again, given the fact that I already determined the value of world prices that are here equal to 1, I calculated the DD from this formula. Then I can calculate here the price of imports. And that's why I cannot say that the price of imports is equal to 1 because it includes custom duties. So I cannot normalize it to 1. Then the price of domestic goods will be the price of producer multiplied by the tax that we have here. So we announced the tax here and we declared the P above. So I can calculate the PD as a function of these 2 variables. Then we have my GDP that is equal to capital plus labor that we have here. Then we have the quantity of exports, which is the value of exports divided by the price of exports. Domestic demand is equal to the difference between what we produce and what we export, given the fact that I have here the Y in quantity, the X in quantity, so the demand will be also in quantity, right? Then we have total income, which will be, again, I have KS from what I calibrated here. I have WK from what is calibrated here. WL has been calibrated here. LSO has been calibrated here. Then the same for the customs and taxes. They have been, all the terms have been already declared before. So I can calculate the income. And then I can calculate my consumption based on the same equation that I have here, because that's why I told you that in general we do the calibration by copying and pasting from the equations. Then we have the alpha, that is the share of capital remuneration to total value added, and that's similar to the basic and simple models. We have the A that is also identical to the previous models. The beta, it's also identical, nothing new. Those three parameters are different. Why? Because as I said, we will calibrate the AD and AN by dividing my left-hand side divided by my right-hand side, and I will impose the value of sigma that I have here. Why? Because it will be used from those exogenous variables that we have here. And the same thing for gamma. So gamma will be, I remind you just the mathematical statement of gamma. So the mathematical statement of gamma was this one. Just a second. So if I want to calibrate the gamma, I can say that gamma will be equal to x divided by all this bracket. Okay, so that's the value of gamma. And given the fact that sigma x is imposed exogenously, this one is imposed exogenously, we already know the value of this and the value of that and the value of exports, then I can calibrate the gamma. And that's what we have here. Okay, any questions on the calibration? Anything that's not clear in the calibration before we move to the initialization? Any questions?
Why DO is in blue?
Because it's a command that is implemented in GUMS, but this will not change our coding. GUMS will still understand that DO is my domestic demand, given the fact that it was declared before.
Okay, thanks.
Other questions on the calibration? Anything that's not clear in this calibration process? No questions on the calibration, so we can move to the initialization of variables. So as you can see, the initialization process is very similar to what we have done, but now we have to choose a different set of exogenous variables. Why? Because definitely we have a larger number of equations, a larger number of variables, and consequently we will have to choose a different macroeconomic closure. And here, the macroeconomic closure will be labor supply and capital supply will be the same. And then the world prices in general will be exogenous, which makes sense because this means that we have here a small open economy. And if it's a small open economy, this means that it will be a price taker. And if it's a price taker, we can assume that world prices are exogenous. So that's the closure. Any questions on the closure? So we call this model open. We will solve the model again. So now we have exactly the same thing, but we have more parameters, more columns and files that we have here. Okay, so I will run the model. And here I didn't introduce any simulation, right? And what we're told that we have an infeasibility of 4.4 negative 16, which is fine. Feasible solution to a square system. If I close this and I share for infeasibility, there is no infeasibility, which means that my model is working. So now I can run a simulation. Given the fact that I have the rest of the world, so one of the most interesting simulations to run is to see what happens if I have a trade liberalization simulation, meaning that I will remove all tariffs that we have in the economy here. So this means that we will remove the tariffs and we will see what is the effect of removing tariffs on the whole economy. From an economic perspective, which variable will be affected by the tariff removal? What do you think? Which variable
Import
will be
or export.
Exactly. That's the most important thing that will be affected. So first, the price of imports will decrease. And if the price of imports decrease, what will happen?
Demand for imports will increase relative to domestic goods.
Exactly. So this means that in this case, the relative demand for imports will increase compared to the domestic demand. And if domestic demand decreases relatively, so perhaps, and we will see this in the simulation, that producers might be led to produce less because they are facing a fiercer competition from the rest of the world, right? And at the same time, the revenue will decrease. Like Salah ad-Din said, why? Because we said that tariffs are part of the revenue of my representative agent. So this means that its revenue will decrease. And if its revenue will decrease, this means that its consumption will also decrease. So that's why what we want now to see what happens for the economy once this takes place. Okay? So we will run the simulation and see what happens. So now, as you can see, we have an invisibility before because there is a simulation, but then the model converges after 25 iterations to a solution, to a feasible solution to a square system. If we look at the results of this code, so I will just a second. So that's the new file that we have of simulating a decrease in of the tariff removal. So let's now go through the results to interpret them. We said that the simulation deals with the tariff removal. So clearly, the immediate effect will be, what will be the immediate effect? What do you think?
Import prices.
Import prices will decrease, and that's what we have here. So import prices will decrease for all goods. And if import prices decrease, clearly imports will have to increase, and that's what we have here. So imports increase and import prices decrease. At the same time, if we import more, in theory, the domestic demand, like what Nadine said, has to decrease because import products are more, interesting from the consumer perspective now. So that's why the domestic demand will decrease. We can see that the decrease in the domestic demand is higher than the increase in imports, and adding to this, the revenue decreases. And why the revenue decreases? So Salah ad-Din said that the revenue decreased because, if you remember, tariffs were part of the income of our agent. So the decrease in tariffs will reduce its income. And if income decreases, this means that my total consumption of the two goods will have to decrease. Okay? If we consume less, this means that we're going to produce less because there is less demand. And if there is less demand, so this means that labor supply and capital, labor demand and capital demand should decrease. But now the sectoral dimension is interesting because there are some differences between the two sectors. Clearly, labor supply and capital supply didn't change by assumption. Now what we want to see, why capital decreases in agriculture, labor decreases in agriculture, but capital increases in industry, the same for labor, and the production of agriculture decreases, but the production of industry decreases. How we can explain these patterns? What do you think? Based on what we have here, have a look at this table and tell me why shall we expect, based on that, an increase in the production of industrial goods and a decrease in the production of agriculture goods. What happens? Bearing in mind that labor supply and capital supply are exogenous. So what do you think?
But did we remove tariffs for both goods, for both agricultural and industrial goods?
Yes. What do you think? Imports of agriculture are more competitive. What do you mean by that? So what do you mean by imports are more competitive? Because in general, we talk about competitiveness of exports. You mean imports are less expensive, or? The elasticity of substitution is assumed to be constant, so that's fine. No, we assume that it's constant everywhere. Let's look here at the behavior of imports. Which imports increase more, of those industrial ones or agricultural ones?
Industrial.
Industrial ones increase by 19.6%. Okay. At the same time, the demand for domestic goods of industrial goods, they decreased significantly by 32% or 33%, but the domestic demand for agriculture decreases by 13%. Let's see here what happens for exports. We can see that exports of agriculture goods increase by 45%, while those of the industrial sector increase by 22%. So this means that at the end of the day, producers, an important thing in order to be able to interpret this, we have to keep the structure of the model in mind. Because if you remember, we said that the y, just a second. So the y is equal to d plus x, right? So if my x increases for agriculture a lot, but the demand for agriculture decreases. So this means that the y of agriculture should increase or decrease. In theory, bearing in mind that I'm looking at the agriculture sector, we should have expected that it has increased, right? But here what we obtain is a decrease in agriculture and an increase in industry, relatively speaking. Why is that the case? Why the production of industry increased while the production of agriculture decreased?
Because the abroad products, agricultural products are more cheaper than the domestic ones, probably after the tariff removal.
Which products are more?
The agricultural products abroad, the imported ones.
Okay,
Since
so
they
for
are
the-
cheaper, the domestic production is lower for the agricultural goods. We import more than producing inside.
So we import more of which one?
Agricultural goods.
No, we import, the rate of change is higher for industry, not for agriculture. So here,
But at the same time, the production for agricultural goods, the domestic production, right, is Y. Y refers to domestic production.
yes, so here this Y increased and this Y
Yeah,
decreased.
for the agricultural goods is less, the domestic production.
No, I cannot hear you.
Sorry, Chahir, now? Do you hear me?
Yes.
Maybe my microphone is a bit broken. So what I'm saying here, the Y for agricultural goods is lower than the Y for industrial goods. The production, domestic production, I mean, is because minus, no?
Yes, exactly. So for agriculture, it decreased, but for industry, it increased. So that's,
Yes.
that's what we're trying to interpret now.
Yes, so what I'm saying, since it's decreased for the agricultural goods, the domestic production, so it means they import more from the outside. That's why they don't need to produce inside.
So they don't want, they
don't need to produce inside.
Yes, but I mean, the counter argument I'm saying is that the rate of change of agricultural goods is lower than the rate of change of industrial goods, as you can see here.
Yeah.
So is the elasticity of substitution, the elasticity of substitution, yes, is the same for agriculture and industry. What else? What do you think? How we can explain this pattern of the two sectors?
I think it's maybe depend on labor market.
Labor, why labor?
It's maybe the industry, it's depend less labor than agriculture.
No, it relies on more labor than agriculture. But the idea here is that,
so
I mean, this part is easy to interpret, because if we understand why the Y of agriculture decreased, we will see that the demand for capital in agriculture and the demand for labor in agriculture decreases.
Yes.
And given that Y of industry increased, so the demand for capital and the demand for labor increases in the industrial sector. But what we want to see is, why did we have this change in Y? That's the missing link that we want to analyze. Why production of agriculture decreased and production of industry increased?
Can you give us a hint?
Well, let's look at the behavior of prices. What does P represent? That's the price of
producer.
Of producer, exactly. So what happens here in the economy is that the producer price decreased for agriculture more than for industry because of this competition, which made domestic producers less interested in the domestic market. So that's why they decide to export more of the agricultural goods to the rest of the world. And that's why the exports of agriculture are more important than industry. So they allocated their products to the rest of the world instead of the domestic market. That's on the one hand. On the other, given the fact that income decreased and that the demand addressed to both of the two goods, in theory, must decrease because of a lower income. But we have also to bear in mind that there is a price effect. And the price effect shows that the price of agriculture here decreased more than the price of the industry. And that's why there is this reallocation from the domestic market to the exports market. So this means that we're going to export more of this good. And if we combine higher, I mean, this will explain how we can have a balanced or a trade balance at the external level, because we have an increase in exports and we have an increase in imports. So now we're able to explain why we have an increase in exports along with the increase in imports. What we still have to see, why in this case we're going to increase the production of Y and decrease the production of to increase the production of industry and reduce the production of agriculture. Because if we look at the two sectors, which one is more labor intensive?
Agriculture.
Agriculture. So we have in agriculture 10 labor and 2 capital. And for industry, it's the inverse, right? So this means that if the production of labor, if the production of, sorry, yes, if the production of agriculture decreases, this means that labor will be more affected by this decrease compared to capital. And that's why here wages of labor, or WL, is -13 while WK is -5. This is due to the fact that we reduce the demand of labor, and this affects my income. So there is here a significant decrease in income, right? Let's look at the share of consumption of agriculture with respect to industry. Which one is higher in the base year? It's the consumption, right? And given the fact that the price of agriculture goods has decreased a lot, so in this case, producers will reallocate their products to the export market, which will make the quantity of agriculture good available on the domestic market lower. And in any case, they will reduce their production because the market itself became more competitive and they will not be able to face this competition. So that's why they will reduce their their production of agriculture goods. But at the same time, the decrease in prices of industry are relatively lower. That's why they might still satisfy the domestic production because the shock is less severe. And this consequently will be reflected on the price of consumption, which is a weighted average of both of the two prices. And again, with the same ratios for the price of domestic goods that include taxes, and taxes have not changed. So the rationale behind this, as you can see, that's really the way we analyze the general equilibrium framework, where we have different forces at the price level, at the demand level, at the internal and the external level, and how producers will reallocate their basket of, what they sell at the domestic market and at the international market because of this change in relative price, okay? And clearly, an important thing also that you have to take into consideration is this relative price story, because as you can see here, import prices, they decreased. And at the same time, based on our model, we had a term where we had the PMW divided by P. So our P here decreased less than PM. from the model. If you remember, I will show you the model just to remind you. If you remember, we had this term here, this one. So if import prices decrease relatively to the P, I mean our domestic prices, this will affect exports. And that's what we have here in the results. Because while the world prices were constant, our denominator decreased. So that's why our export increased significantly in this model. And domestic producers, they are becoming more and more interested in the external market rather than the internal market. So any questions on the results? Any questions on the open model? Anything that's not clear? Any comment? Okay, I don't think we'll have time to start the dynamics because it's 10 to 7 and there are some things I want to highlight before we finish. So in general, perhaps I will say in a few words the idea of the dynamics. So in general, I mean, as you have seen in different models, we started from a very basic model without government, with just one good, and we added gradually different things. First, a second sector, then the government with the rest of the world, and we can even add further details to the model. If you want to introduce the dynamics in general, the dynamics, as I said, will be mainly driven through the investment and capital. Why? Because what I invest today will increase my capital stock tomorrow. And my capital stock tomorrow will be used to produce more, right? Because my capital appears in the production function. So that's the basic idea of the dynamic model. So the basic idea of the dynamic today and how this affects my model tomorrow. Okay, we have to add an equation on the capital accumulation through investment. We might add an equation on the technological change, which is the parameter A that we have in the production function, and that will be updated sequentially. And we can add a lot of things in the dynamic model. As I said, we have two types of dynamics. We have the intertemporal dynamic and we have the sequential dynamic model. The intertemporal dynamics model, we assume that time is continuous. But for the sequential dynamic, time is discrete. So this means that intertemporal modeling, we see the adjustment process itself. But for sequential modeling, we consider time as a discrete intertemporal adjustment. So in other words, it's a series of sequential equilibrium. So that's, I mean, very, very briefly, the idea of the dynamics that unfortunately will not be able to see the dynamic model. But I will send you the slides anyway of the dynamic model for your reference. So, I mean, at the end of this training, I want to highlight 5 important things. First, as you noticed, we adopted a very gradual approach that is theory-based. So we really look at the theory. I mean, whenever we started a model, we have first to understand the theory behind. We have to understand the data that we need to run the model before writing the code, because without investing a lot in understanding the theoretical framework of the model, will not be able to become real modelers. That's 1. 2, whenever we work on real data, we have to bear in mind that every economic flow that we have in the social accounting matrix is represented in the model through a variable and or another important point. Another important point is that all equations are represented through data. So we have to make sure that we cross-check the data with the model, and that's the second point. So the first point is that we have to understand the theory well. The second point, I mean the model itself, we have to make sure that we cross-check that all the data we need is there, that all the economic flows in the SAM are represented in the model. All the model is based on data from the SAM. That's the second point. The third point, GAMS and CGE modeling, like any other econometric technique, are mainly based on a learning by doing process. So the more you will invest in it and the more you will work on different models, the more you will master it and you will be able to develop your own model. From my personal experience in CGE modeling, I started on my own using a very basic model, and then I built on basic and simple models, more complicated models, until I constructed Egypt's model using real data. So the more you will do it on your own and the more you will face errors, and you try to correct these errors by searching in GAMS forums or searching online or getting back to colleagues and so on, you will really be able to master this modeling tool. Fourth, I highly recommend starting after this training workshop, if you wish, I mean, work on your own model. I will send you the codes, the materials, and there is a very rich source of CGE modeling that is called PEPNet. If you write on Google PEP CGE, you will get a very interesting website that includes a host of codes for different, I mean, opt for the easier path, because in general, there is a school in CGE modeling where you just take a code that exists, you calibrate it to your data, and then you run the model, you run the simulations. This is not really beneficial because you will not be able to change the code or to make your own contribution in terms of modeling. So that's why before getting a code, because you will find dozens of codes on internet, you will have really to understand very well each and every single line in the code, okay? So with that, we can conclude this session. Ramaj will send you a folder that includes 3 folders, a folder for codes, a folder for the references, and a folder for the presentations. Second, she will also send you an evaluation form. Please fill it, because this helps us improve the courses that we do. I know that, I mean, it's a short course online, because ideally we should have met somewhere, either in Egypt or in another Arab country. But unfortunately, it was not doable. So please fill the form, because it's very important to us. Third, all the recordings and the material will be uploaded on the website of ERF, and you can download them. And last but not least, and most importantly, I would like to thank Ramaj for all the help, and Namis for all the IT help as well during these 4 days. And I would like to thank you all for your attention, and for, I know that Zoom lectures are boring, and that in-person lectures are much more interesting, but that's the second best that we have to opt to for now. And don't hesitate if you have any questions, comments, you have my email, and that's it. Thank you a lot, and I hope you enjoyed this short course.
Thank you, Dr. Chahir.
So if you don't have any questions, we'll end the session now, and we'll see you hopefully soon in person in one of the ERF events. Thank you, and see you soon.